Okay, so let's go ahead and look at some examples for solving for the inverse. Now remember, this is just going backwards. All right, we're given the answer, and now we need to find which angle will give you that answer. What makes this tricky is that there are pretty much two solutions for each of these, right? So we've got two solutions in 0 and 2 pi. And then we have infinitely many solutions if the angle continues to go around the unit circle over and over and over and over again. So let's go ahead and first find our two solutions here, okay? So for example number 1, which two angles will equal to the square root of 3 over 2? All right, which angles will give you, and I'm going to emphasize that it's positive, right? So another way of saying this is we can say the cosine inverse of which value is equal to t, right? So which value gives me angle t? So I'm gonna get a little helper out right now. I'm gonna post my angle right here, or all my angles here, and let's see which quadrant do we have which quadrant is cosine positive in, right? So all students take calculus, right? So cosine is positive in quadrant 1, and it is also, let's highlight the quadrant. I don't want to write more stuff. So right, so it's positive in quadrant 1, and cosine is positive in quadrant 4. So let's find which two angles give me radical 3 over 2. Think about radical 3 over 2, right? This is the long side, right? So long, right? So which angle will give you the long one? So oops, let me get my other color. So this is my long side here, right? So this is going to go with this angle there, and this is going to go with this angle right there. So both of these angles are going to give you positive cosine. Okay, so let's go ahead and let's write our answers down. So what are those two angles? So first of all, this first angle right here is going to be 30 degrees, right? So this guy is just going to be 30 degrees. And then if we go all the way around, right? If I go all the way around, what will this angle be? Well, I know the whole thing's 360, and I'm going back 30 degrees, right? That's the special right triangle. So now I'm at 330. So my two answers are going to be t is equal to 30 degrees and 330 degrees. Okay, but that's in degrees. What about radians, right? 30 degrees is pi over 6 in radians, and then 330 is 11 pi over 6 in radians, right? 6 is double 12 and less than 1, so it's a little bit less than 2 pi. Okay, so that's the first part. So that's our first part done. Now, what about the second part, right? Now we've got to find, what about where are all the solutions? Okay, so the way we're going to do this, we're going to just make this a little bit easier. I'm going to take 30 degrees, and that angle is going to repeat every 360 degrees. So I'm going to take 360, and however many times I go around the unit circle is how many times I'm going to get a value. So I'm going to multiply it by n, right? Where n is how many times I've gone around the unit circle, right? N is going to be equal to just like positive numbers, 1, 2, 3. It can also be negative numbers too, right? Negative 1, negative 2, negative 3, because I can go backwards the other way. All right, same thing with 330. So the way I can find all the answers, I can take 330, and then I can just add and subtract multiples of 360, right? And then same thing, your n is equal to the exact same thing. Let's do it with radians now. So I'm kind of running out of space here. Let's erase some of these. Let's erase these values right here, right? N is going to be the same for both. So for our pi over 6, right, same thing. I'm just going to add multiples of a revolution. 2 pi is a revolution. So I'm just going to add multiples of 2 pi. And then for 11 pi over 6, same thing. Add multiples of 2 pi. And for all of these, n is equal to positive and negative integers. So I'll say positive and negative integers. So 1, 2, 3, 4, and then so on, right? I didn't put 0 since we already had them here. All right, let's look at the next example. So my next example, I've got the sine inverse of negative 1/2. All right, what's the sine inverse of negative 1/2? So I'm looking for answers that are between 0 and 2 pi, and then I'm going to look for all the solutions here. Okay, so I'm going to look for whatever's in between 0 and 2 pi, and then I'm going to find all the solutions. So sine inverse of negative 1/2. Where is that going to be? Let's go ahead and erase some of these values here. Let me rewrite this. This is going to be all students take calculus. Okay, so where is sine negative? Sine is going to be negative here, right? Because only tangent is positive there. And here, only cosine is positive there. Right? And plus, sine is a y value, right? So that makes sense. It should be below the x-axis because that's how it goes negative. That's how it goes down. So 1/2 is my short side. So think about what's your short side going to be? This is my short side. So that's going to go with this angle right here. You know what? That's okay. We don't need that. And then where's my other short side? This is my short side here, which is going to go with this angle. So the two angles that I need to know what is this angle and then this angle right here. Well, we have them, 210 and 330. So I'm done. So I've got my answer here is going to be, let's write it right here. My answer is going to be 210 degrees and 330 degrees are going to give you a value of negative 1/2. But in radians, so 210, that's a little bit more than pi, so that's 7 pi over 6. 330, that's a little bit less than 2 pi, so 11 pi over 6. So those are, that's the first part, right? Those are all the angles between 0 and 2 pi. Now for the second part, we're going to do what we did before. I'm going to take 210, and I'm just going to add multiples of 360. I'm going to take 330, and I'm just going to add multiples of 360. Then I'm going to take 7 pi over 6, and then I'm going to add multiples of 2 pi. And then I'm going to take 11 pi over 6, and then I'm just going to add multiples of 2 pi again. And that should give you all the answers, right? And it makes sense. If I keep going around the unit circle again, I'll get negative 1/2. I go around again, I get negative 1/2. I go around again, negative 1/2. So every time I go around the unit circle, I'm going to get a new answer. All right, so for tangent, it's going to be a little bit different because the tangent repeats its values after you go halfway around the unit circle, which we will see a little bit more next week. So, but let's go ahead and let's just find all of the solutions of tangent here. So, okay, I want to know at which angle value gives me a tangent of 1. Ooh, this one's going to be a little bit tricky, right? We're going to have to know all the angles of tangent in the first quadrant. So let's go ahead and list some of those down right now, right? So tangent of, oh yeah, let me add my little, all right, let me add my little circle here. Let me just scoot it over just a little bit. Right in the middle is perfect. All right, so let's go ahead and add all of our tangent values. So tangent at 30 degrees, all right, this is going to be my long side. I'm sorry, this is going to be 1/2 divided by radical 3 over 2. All right, it's the y value divided by the x. So that is going to end up giving me radical 3 over 3. Then at tangent of 45 degrees, I end up with radical 2 over 2 divided by radical 2 over 2. That's going to give me a tangent value of 1. And then for the last one, I end up with radical 3 over 2 divided by 1/2. So that just ends up giving me radical 3. So it's really good to know those 3 tangent values. The other ones are going to be pretty easy to figure out. At this point right here, we have the point 1, 0. So your y value divided by your x, that's just 0. And then that means this one's got to be undefined. So at negative pi over 2, we are undefined. All right, let's ignore this. We don't really care about this right now. That's more for next week. Okay, so tangent inverse of 1. Okay, so first of all, where is tangent positive? Tangent is positive. Let me go ahead and erase this. Tangent is positive in quadrant 1, right? Tangent's positive in quadrant 1, so it's all students take, and we're positive in quadrant 3. All right, so quadrant 1 and 3, tangent's positive. So in which of those quadrants do I get a value of 1? So we can see that at 45, so that angle right in the middle, and then same thing there. So our answer here is going to be 45 degrees and 225 degrees. And then in radians, we've got pi over 4, and what is that going to be? That is a little bit more than pi, so 5 pi over 4. So 5 pi over 4. Those are my two answers. If we want to find all the solutions, so just like we did before, we're just going to do 45 plus 360, and we're going to do 225 plus 360n. Then I'm going to take pi over 4 plus 2 pi n, and then 5 pi over 4 plus 2 pi n. Okay. Next one. Tangent inverse is equal to radical 3. Let's switch this up. Why don't we make this negative? Let's make this a negative radical 3, right? So it's going to kind of change our answers a little bit here. So for radical negative, so which quadrant is tangent negative in? Well, tangent is negative in the second quadrant because only sine is positive, and in the fourth quadrant, right? The fourth quadrant, I have only cosine is positive there. So which of those will give you radical 3, right? So if we look at quadrant 1, notice that the 60-degree angle gives you radical 3. So that's going to match up with this one, right? And then it's also going to match up with this angle in the fourth quadrant. All right, we don't need this one right now. So now we have our two angles, right? So 120, right? Since these two match up right here, and then also 300 since it matches up right there. So see how reference angles and your understanding of special right triangles is kind of helping me out here. All right, let's go ahead and finish this off. So this 120 is 2 pi over 3, and then 300 is 5 pi over 3. And then just add the 2 pi n and the 360n, and you'll get the rest of the answers.